What's going on, besties? In this video, we're going to be talking about T7 math, specifically conversion for fractions, decimals, and percentages. Let's get started. So let's start by taking a closer look at breaking down a numerator and denominator. So the numerator is the number that is above the fraction line and represents how many parts of a whole that you have. So here we have an example of 3/4. The top number 3 is our numerator. The denominator is the bottom number below the fraction line, and it represents how many equal parts of the whole are being divided. So in this particular case, our denominator would be 4. To make it easy, the denominator helps us understand the total parts that we're considering, while the numerator tells us how many of those parts that we're actually focusing on. To understand fractions better, let's visualize a pizza, often served in 8 uniform slices. To mathematically model this, we can represent the whole pizza as the number 1 and divide it into 8 equal parts, indicating the division of those parts. This means that each piece represents 1/8 of the entire pizza. If you consume 2 slices, that equates to 2/8. Now let's imagine a scenario where the pizza is sliced into quarters instead of 8s. In this arrangement, each piece accounts for 1/4 of the pizza. Interestingly, consuming 1/4 of a pizza is equivalent to eating 2/8 because these fractions represent the same quantity. If you divide the numerator and the denominator by 2/8 would be equivalent to 1/4. This is a demonstration of equivalent fractions, illustrating that despite having different denominators, the fractions can express the same value once they are simplified. Now that we have a better understanding of fractions, let's focus on the concept of place values and understand their application when it comes to decimals. As a quick refresher, consider the number 1,234. It's a familiar territory where many of us recognize the rightmost digit before the decimal as being the ones place. The 4 stands firmly in the ones place, truly representing its face value. Moving 1 digit to the left, we find ourselves in the tens place, where each value is 10 times greater than the 1. The 3 in this place value represents 30 as it occupies the tens place. Progressing further to the left, another leap by 10 brings us to the hundreds place. And in this place, that digit is not just a 2, it also equals 200. And finishing out, moving further left brings us to the thousands place, making the 1 in this place actually 1,000. Now, as promised, we're going to deepen our exploration by introducing a decimal point to the right of the ones place. The decimal serves as a critical role for delineating where the ones place lies. So moving to the right of the decimal allows us to expand our numerical landscape indefinitely, accommodating as many decimal places as needed, each with its own significance. So let's consider this. When we're transitioning from the hundreds to the tens place, we're ultimately dividing by 10. Moving from the tens to the 1 place, we're also dividing by 10. So what name would we give the position immediately to the right of the decimal? What results from dividing 1 by 10? You end up with 1/10 or 1/10, leading us to understand this next position as the tens place. If we move 1 position further to the right from the tens place, what do we call this new position? It results from dividing a 10th by 10, effectively giving us 1/10 of a 10th, which leads us to identify this place as our hundredths place. Pushing even further to the right, we advance 1 more space. What designation does this position hold? Well, dividing a hundredth by 10 is considered as 1/10 of 100, bringing us to 1,000ths place. So in this example, instead of us having just the number 1,234, let's expand it to 1,234.567. What does these additional digits signify? Well, the digit 5 here doesn't simply stand for 5, it symbolizes 5/10. Moving on to digit 6, it embodies 6 hundredths. To make it crystal clear, 6 hundredths can also be represented by placing a 6 in the hundredths place, which is 2 positions to the right of the decimal. Lastly, what does 7 signify? It stands for 7 thousandths. To write this in decimal form, you would place the 7 in the thousandths place, which is 3 positions to the right of the decimal. So zooming out, the concept of place values allows us to extend indefinitely to the right of the decimal, enabling us to represent mathematical numbers with more precision. Next, let's talk about percentages. So percentages are common parts of everyday life. We encounter them in numerous situations, whether it's a 30% discount during a sale, leaving a 20% tip at a restaurant, or hearing that there's a 50% chance of rain in the forecast. Percentages are everywhere. But what exactly do they represent? The term percent derives from the Latin word centum, meaning 100. So essentially, percent translates to per 100 or out of 100. It serves as a method to express quantities by scaling a total of 100 and then describing a specific value as a portion of that 100. So for example, scoring 90% on the ATI TEAS exam implies that in terms of ratio, you have achieved a 90 out of 100. This could also mean 9 out of 10 questions correct, 18 out of 20, or even 450 out of 500, all reflecting the same proportionate relationship to 90%. To adjust larger numbers down to 100, we apply the same operation to corresponding smaller numbers. So for instance, to scale the denominator of 10 up to 100, we simply multiply that by 10. Similarly, we would multiply 9, the numerator, also by 10 as well. This would give us 90 over 100. Thus, percentages function as ratios, representing a particular type of ratio that benchmarks numbers against 100. While seemingly arbitrary, that benchmark of 100 provides a convenient standard for comparison, making it easier to understand and compare different quantities. Viewing percentages as basic fractions offers a clear perspective. For instance, 80% translates to 80 out of 100. As we've learned, simplifying fractions involves dividing the numerator and denominator by a common factor. Here, dividing each side of the fraction by 20, we arrive at 4 over 5, illustrating that 80% is equivalent to 4/5. Exploring another example, 50% is the same as 50 out of 100. Reducing the fraction by dividing both numbers by 50 yields 1/2, logically aligning with the fact that 50% represents half of 100. For smaller percentages like 3% represented by 3 out of 100, further simplification is impossible, indicating that some percentages like 3% are already in their simplest fractional form. Converting between percentages, fractions, and decimals should be a pretty straightforward process when using this method. Let's test our understanding to ensure that we have fully grasped the concept. We've explored how fractions, decimals, and percentages can each represent the same numerical value, highlighting the flexibility of numerical representation. Now, how do we convert between them? I've included a memory trick that is actually found in my study guide to help you bridge this concept of converting between fractions, decimals, and percentages. So let's take a closer look at the conversions going either way. So if we start out with a fraction and we want to make it into a decimal, all we have to do is divide the numerator by the denominator. 3/4 would give us 0.75. Now, if we had to convert between a decimal to a percentage, we would simply multiply by 100 and move the decimal to the right 2 places. The same thing if we wanted to go the other way. If we wanted to go from a percentage to a decimal, we would simply divide by 100 and move that decimal place to the left 2 places. And if we had to take that decimal and convert it to a fraction, we would divide by the place value. We know that 0.3 is in our tenths place, so this would give us 3/10. Let's consider another example of 30%. Converting this into a fraction is pretty straightforward since we understand that percentages are based on 100. Thus, 30% translates to 30 out of 100. To simplify this fraction, both the numerator and the denominator can be divided by 10. Here's a quick trick though when you're taking your test. You can simply just remove the trailing zeros to help you get your answer when you have fractions that are like this. So 30 out of 10 is going to equal 3/10 in its simplest form. Now, to express this as a decimal, all we need to do is identify the tenths place. For 3/10, this means that we're going to place the 3 in the tenths position, resulting in 0.3. This demonstrates 3 distinct methods for expressing the same numerical value, showcasing the interchangeability between fractions, decimals, and percentages. So our first practice question states, convert the fraction 5/8 to a percentage. So we know that we are starting with the fraction 5/8 and we need to convert it to a percentage. So this is really simple. We're going to divide 5 by 8 and that's going to give us 0.625. Now, as we said before, we're going to multiply by 100 and move the decimal to the right 2 times. So we would go 1, 2. This would give us 62.5, leading us to believe that our correct answer is C, 62.5%. What is 0.2 expressed as a fraction? Simplify the fraction. So we know we're going to have to do a little extra math to come up with our answer. So we start with 0.2. We know that for certain as our decimal, and we need to convert to a fraction. In order to do that, we're going to divide by the place value. So as we learned in decimals, that number immediately to the right of the decimal place is our tenths place. So that means that we are going to convert 0.2 to 2/10. But again, we have to simplify our fraction. So in order to do so, we need to find the most common number that can be divided in our numerator and our denominator. That common number is going to be 2. So we're going to divide both sides of our fraction by 2, and that's going to give us 1/5. Do we have an answer that's 1/5? We do. The correct answer for this equation is going to be B, 1/5. Moving on to our last practice question for this section, we have convert the percentage 25% to a decimal. So we start off knowing that we have a percentage of 25% and we need to figure out the decimal. We do this by dividing by 100 or simply moving the decimal to the left 2 times. So in this, we know that our decimal would be behind the number 25 and we're going to move it to the left 2 times. This is going to give us 0.25. But you cannot have a decimal without having a whole number in front of it. So in this case, we want to add a 0. So it's going to equal 0.25. Do we have that answer? We absolutely do. The correct answer is going to be A. I hope that this video is helpful in understanding this portion of the math part of the exam. If you have any other questions, make sure that you leave them down below. I love answering your questions. Head over to nursecheungstore.com where there's a ton of additional resources that are available to you. And as always, I'll catch you in the next video. Bye!